I'd like to introduce to the new folks in the room and reintroduce for the folks in the room, David Simons, our next presenter. Mr. Simons works with the Texas Optimization Program and serves as the engineer for the Texas Optimization Program and Response Team. He received his Bachelor's of Science and Master of Science degrees in Civil Engineering from UT Austin. David worked for an environmental consulting firm in Dallas, holding positions with the city of McKinney and Taylor, and worked for a civil engineering consulting firm in the Austin area prior to taking the position with TCEQ in 2013. In addition to the administrative duties for TOP, he provides technical assistance to public water systems, TCEQ regional offices, conducts on-site evaluations for surface water treatment plants, and has been focusing on low-pressure membrane plants. Give him a welcome. Yeah,
Thank you, Catherine. All right, so we're going to go through just some common issues that we see in low-pressure membrane plants throughout the state. So just outline of what we're going to talk about, just give you an overview of low-pressure membrane requirements, what we've seen as we've gone out, talk about resolving some of these common areas of noncompliance, and then I'll briefly tell you about some initiatives that TCEQ is taking. So, just very basic here, low-pressure membranes, why does anybody install them? And it's typically to obtain cryptosporidium and giardia removal credit during the treatment of surface water and groundwater under the influence. The low-pressure membrane treatment, on the scale of conventional treatment, it's much more complicated. You've got direct integrity tests. You may call them ITs or air hold tests, but those are necessary to prove that the membranes are intact. You've got a lot of online turbitimeters. Automatic alarms and shutdowns are critical in low-pressure membrane plants. You've got some special monthly operating report requirements, and there's lots of other requirements to prove that your membranes are working correctly. Sometimes vendors may claim, as they're trying to sell their product that, these plants run by themselves. You just push a button and you don't need much operator oversight. Not true. I mean, you still need your operator paying attention in a low pressure membrane plant. So the requirements are mostly site specific, and the reason is in our rules, there are 290 rules, it doesn't cover all the requirements for operating low pressure membrane plants. Most of the requirements are site specific for your installation, and they're in TCEQ approval letters. You've got one letter that contains details like the approved model of the membrane, the mode of operation, maximum allowed flux rate through the modules, duration of filtration cycles, which influences the capacity of the membrane plant. Then you've got a DIT parameters letter, and that contains the minimum of pressure allowed during a direct integrity test, and also the maximum pressure decay rate that's allowed during or UCL, upper control limit, that's allowed during a DIT. You've got your concentration time study or CT study letter, and that defines how pathogen and disinfection and activation credit is awarded through the treatment plant. And then you've got a bin classification letter that tells whether your plant is bin 1 through bin 4, and each of those has different cryptosporidium removal requirements. So during a TCEQ plan evaluation, we take those approval letters and some of the rules that do cover low pressure membranes, and we compare it to your plant to see if everything's matching. I will say it's very common to find issues in membrane plant design. I'll give you an example here. The TCEQ requirements for, let's say, turbidity shutdowns, maybe weren't followed when the control system was programmed. Maybe you've got something that's not right and is not quite compliant in your. That's pretty typical. Also, misunderstanding of operating and reporting requirements. It happens pretty frequently. So during these evaluations, if we're doing this, we're providing technical assistance to the plants. We're trying to help the operators understand the requirements. We've put together a couple of documents that are intended to help the operators and as well as your design professionals. We've got the low pressure membrane treatment plant checklist, and it's got a link right there for it on our website. You can also just go to the TCEQ homepage and say search on low pressure membrane checklist, and that'll get you to the right page if you don't want to type in the whole list there. And what this document does is, helps the operators and their managers understand how to go back to the membrane vendor if there are design issues. It's really the intent of it is to break down all these complicated requirements into a practical, testable list. I mean, it is a long list, but if you go through it step by step, you don't even have to understand necessarily completely what each item means, but you can identify issues. So the way the checklist is set up, and here we have an example from the treatment section, and it's pretty typical. You've got a question or a statement. If you can answer yes to the question or statement and check the box off for that item, there's probably no issue. If you're on a particular item in the checklist and you can't check the box, well, maybe there is an issue there. And, it's not exactly what we're not exactly doing what this says. So, And then even if you don't understand what needs to be done to correct it, at least you know it's an issue, and you can reach out to us at TCEQ for assistance figuring out what the issue might be. We also created a companion document for the checklist, this common issues with low pressure membrane treatment plants. Got the link there. It's on the same web page as where the checklist is. So if you've gotten to the checklist, just go down a little bit more and you can get to the link to the common issues. This document provides a very detailed explanation of what every checklist item means. So, we saw one that said, is the correct model of membrane module installed in the plant? And you're going, well, what does that mean? You can go over to the like numbered item in the common issues and get a very detailed description of what it is we're looking for. So we think that, this document in particular is really helpful for the operators, the engineers, and the vendors to understand, what is it, we're trying to get to with that checklist item. So let's move on to resolving common issues. If you find an issue while you're using the checklist, a potential issue, not sure one way or the other, at the end of the checklist, there are some technical assistance contacts within Water Supply Division. Those that are listed there are on our technical review and oversight team. They're the folks that write the exception letters for the membrane plants. If it ends up being a really complicated question or, just needs some field verification, they may refer it over to me. I do the on-site evaluations. So you may get to me, or they may be able to resolve whatever the issue is. And we're absolutely willing to discuss whatever the issues are with your engineer and your vendor if you're just hitting the wall there. So we'd be glad to do that. As I mentioned before, it's not necessary that your operator completely understand every item in the checklist. It's just a tool to help identify potential issues. And as far as us working with you, providing technical assistance, we would prefer to do that outside of a compliance investigation. What the team I'm on, we're technical assistance providers. We're not in compliance or enforcement. We're not PWS investigators. And so we can approach your issues a little bit differently than a PWS investigator does. When they come out, they've got to handle everything as a compliance issue, and write you up for it. So it's just a lot less stress on you to try to get technical assistance from us than just wait and let the PWS investigator hit you up during a comprehensive compliance investigation. All right, so resolving some common issues. What about direct integrity tests? State this up right now, and so there's no misunderstanding. The results of your direct integrity test, your pressure decay rate and the lowest pressure during the DIT, that is more important by far than turbidity is an indicator of whether your membranes are working right. The direct integrity test, is designed to determine if there are holes in your membranes that are large enough to let cryptosporidium and giardia pass through. And honestly, low pressure membranes that maybe aren't intact, that do have holes, they can still have really low turbidity. So just keep that in mind, that turbidity is not the most important thing for low pressure membranes. So what's a common issue? It say here, operators are not aware that the membrane control system or SCADA are providing incorrect DIT results. And in the checklist, there's a procedure in there that says, how do you check that? Write down the results. There's actually a little chart in the checklist that you write down your start pressure, your minimum pressure, your test duration, shows you how to calculate your pressure decay rate in PSI per minute. And then you can compare that to the data that's saved in the control systems. Really the most common issue as far as this goes is our SWMR form expects you to report pressure decay rate in units of PSI per minute. Sometimes we get to plants and the operators are reporting in PSI per second, which is much lower number than the decay rate per minute. And they think they're reporting PSI per minute, but that's not actually the case. Nobody explained to them that the control system is giving them these units. So running through this checklist, may be an easy way to figure out, oh, wait a second, our pressure decay rate's actually much higher than what we've been reporting. Some other DIT issues. You've got the wrong number of membrane modules in service. Our DIT parameters letter that I described earlier specifies how many membrane modules must be in service in each membrane unit to make the DIT valid. If you have fewer modules either in service or you've taken some out, your DIT parameters letter is no longer valid. In some cases, you valved them off, whatever the issue is. If our assumptions about what the number of modules that are actually in service in a unit is incorrect, we have to revise your DIT letter. So you need to let us know that you've got the wrong number of DIT or modules, or the numbers don't match up between the DIT letter and what's really happening. And we can revise your letter at that point to match actual conditions. Still on DITs, it's another common issue. If a membrane unit fails a DIT, we do have requirements, such as the membrane unit that's failed cannot be returned to service until it passes a subsequent direct integrity test. The checklist and the companion document describe how to intentionally, cause a DIT failure. It's not really a failure, but you're venting pressure manually during the DIT. So to the control system, it looks like, oh, we just had a failed DIT. But you do this and then observe how the control system responds to that failed DIT. If for instance, you run this and it fails, and then the control system puts it through a backwash and then sends it back in service, no, that's not compliant. You have to pass a DIT before you can return that unit to service. Mode of operation. This is really important. Your membrane approval letter specifies the mode of operation, deposition or crossflow. So I put up here a couple of diagrams. So this is deposition mode is the top one. Just consider this, the rectangle is your membrane unit. The the diagonal line through there is the actual membrane surface that separates the filtered water in light blue from the unfiltered water in dark green. So in a deposition mode operation, your unfiltered water comes in, all of it passes through the membrane modules to become filtrate and goes on out as filtrate. The other potential mode of operation is crossflow. In this one, it's a little bit different because your unfiltered water comes in, but then there's a flow of water that's directed across the upstream side of the membranes. It's there to scour particles off, and that crossflow is then removed on the unfiltered side of the membrane module. So, I mean, most of the water goes through, but there is a component that doesn't go through. The real issue here is if you're in crossflow mode, which is also sometimes called recycle mode or suspension mode, because of the way it works, it actually concentrates pathogens on the upstream side of the membranes. And if we have approved you to operate in deposition mode, and y'all may call it dead end mode or something like that, and we have set your DIT approval, your parameters, according to that operating mode. For crossflow mode, we need to go back and change your approved DIT parameters. So that's really the issue there. If you're operating submerged membranes, just note that they only operate in a crossflow suspension mode. But when I say your DIT letter has to be changed, I mean the upper control limit in your DIT parameters letter is dependent on the mode of operation. So please let us know if you've changed the mode of operation, or go back to the approved mode of operation. But if you want to stay operating in something we haven't approved, then please ask us to revise your DIT letter. Here's another one. It's not exactly directly related to membranes, but it's the use of a required coagulant. Operators sometimes think that, as I mentioned before, getting equally low turbidities with or without the use of coagulant means it's okay to stop using a coagulant. Well, the pores of the membranes and low pressure membranes, they are much larger than virus particles, and uncoagulated virus particles will pass directly through the membranes. So if you're not using a coagulant and we know that, then we're going to tell you have to get all your virus credit has to come through inactivation. So if you have a number, on your SWMR that says you only need 2 or 3 log virus inactivation, we think you're using a coagulant, and that's how we've approved you. It's not okay to be approved to use a coagulant and stop using a coagulant with low pressure membranes, because the filtrate turbidity does not equal virus removal. Some CT study assumptions that we find. If you're injecting your disinfectant or you're monitoring your residuals in different locations than what we approved in the CT study, then there's an issue there that we need to look at. If you change the type of disinfectant, the arrangement of treatment units, anything that doesn't match the CT study, then your CT study may be invalid. So some examples, like moving an injection or monitoring location may invalidate your contact time calculations. If you adding a disinfectant in the middle of an existing disinfection zone is not allowed. You can only add disinfectants at the beginning of a disinfection zone. Another one that we've seen some is your plant's been approved to use chlorine dioxide in one of the disinfection zones, but y'all are reporting free chlorine. That's not okay. If you're unable to measure a chlorine dioxide residual in that zone, you can't report a different residual like free chlorine. And the reason for that is, free chlorine readings below like 0.5 milligrams per liter are often false positives caused by interferences with the DPD test method. Manganese interferes with the test method. There's lots of things interfere with the free chlorine DPD test. So, we're not comfortable that you have actual free chlorine if you've got a number that's well below 0.5 milligrams per liter. So it's a good idea to verify your CT study and ask us for any help if you need it revised. Another CT study thing is misreporting flow rates through disinfection zones. So if you're familiar with the SWMR, you know that on page 2 of the SWMR, you report your daily volume of raw and treated water. Raw water pumpage, treated water pumpage goes there. On pages 4 and 5 in the disinfection process table, you're supposed to report instantaneous flow rates, not a daily volume. So if you're entering the same number on page 2 that you are entering on page 4 or 5, you're probably underreporting the flow rate. And I'll just give you an example to try to clarify what I'm saying. So let's say a plant pumps 1.5 million gallons, of raw water during a 24-hour period. On page 2, you would enter 1.5 under the raw water pumpage. And then let's say on page 4 and 5, they also enter 1.5 in the flow column. That is not an instantaneous flow rate, and it shouldn't be reported on page 4 and 5. If the plant was actually only running for 8 hours and treated water at a constant flow rate, the actual instantaneous flow rate would be 1.5 divided by 8 hours times 24 hours per day. The flow rate was 4.5 mgd, not 1.5. So that's an illustration of how much of an underreporting of the flow rate, and that completely messes up the CT calculations on page 4 and 5 if you're entering the wrong flow rate. And just to illustrate this, we'll go to the previous example that I was talking about, the 1.5 million gallons of raw water in 24 hours, but the flow rate of 4.5. The correct way to enter that is, of course, here under raw water pumpage, 1.5. And then you can see over here on page 4 and 5, we've got the 4.5, on both of those days. Interestingly, this second disinfection zone, the number is half. And that may be just a part of your CT study. So maybe in disinfection zone 2, you've got 2 parallel units, 2 SED basins in parallel. And we just want you to report the flow rate through one of the SED basins. So that's why that may not necessarily be the same number in each disinfection zone. The only time pumpage and flow rate would be the same numerical value is if the plant treated water continuously at a constant flow rate for 24 hours straight. And no plant really operates that way. So it's when we see that, we can pretty much tell right away that the flow rates are being reported incorrectly. Keep in mind that in the SWMR, the units over here, even though this says MGD, you're really reporting a volume of 1 million gallons, that was in that 24-hour period. So, but million over here, so this is really a volume, and this is a flow rate, an actual MGD here. If you're pumping at 3,000 gallons per minute, and you'd put in here, 3,125 GPM. That's equal to 4.5. If you need to convert it from GPM to MGD. Another issue. So for IFE turbidity on your membrane units, not recording the individual filter effluent turbidity, IFE turbidity at 5-minute intervals is a compliance issue. When we wrote your approval letters for the membrane plant, we expected that you would be creating a 5-minute record of IFE turbidity throughout the day, You were using that 5-minute data to trigger turbidity shutdowns and report data to us from that. If you're actually reporting your maximum daily IFE turbidity from a data trend line or a 15-minute record, et cetera, that's not compliant, and you really need to create a 5-minute record. So the turbidity shutdown this is how it's supposed to be set up, and your plant may or may not be set up this way. A turbidity shutdown is supposed to occur when 2 consecutive 5-minute readings, IFE readings, are above 154 milli-NTU. If you shut it down at that point, there's no violation, and you shut it down and you pass a DIT before putting it back in service, that's fine. That's great. There was a shutdown, and you pass a DIT. It's okay to put the unit back in service. If your control system uses a timer instead of the 5-minute records, it's possible to have 2 consecutive 5-minute readings in that 5-minute record without a associated turbidity shutdown. Now that would be a violation. If we saw, oh wait, you got 2 readings here and the unit didn't shut down, you didn't meet a treatment technique requirement. And I could go into detail about how that happens, but it's explained in the common issues document more thoroughly, and it takes a little while to explain why timers can force you into situations where you might get a violation. Another note is, if your operators are digging through trend lines to report data in the SWMOR, this really takes away time that they could be doing more productive things, and it would just be to your benefit to get that 5-minute report automated, so they can just get a copy of the report and stick the data right into the SWMOR without spending hours looking through trend lines. You can ask your vendor or your SCADA contractor to program the control systems to create a 5-minute record, and use that record to trigger the turbidity shutdowns. We've actually created a template on that same website where the checklist and the common issues document are. It's just a template of, here's an example of how you can set up a 5-minute record of, what records should go into this. And cool thing about our template, and you can have your contractor do it just as well, is you enter in all the 5-minute data, and then the spreadsheet tells you, all right, here are the values you need to report in the SWMOR. It goes through and picks out the maximum turbidity. It lists up there what your pressure decay rates and anything like that were. So it's really handy. I mean, it even tells you, CFE turbidity. If you enter that in there, it'll tell you what values to use. So if you're curious, definitely take a look at that 5-minute data record template we have. Another common issue is improperly programmed turbitimeter controllers. And I go out to plants, and sometimes, I'll see that the turbitimeter is reading 0.5 NTU, but the control system is recording 0.2 NTU. Oh, what the heck is going on? That's a spanning issue. The low level and upper and high level from the turbitimeter controller, it's programmed to transmit, let's say 1 or 0 to 1.5 NTU. It doesn't match and it then sends out a 4 to 20 milliamp signal. The control system's been set up to interpret that 4 to 20 milliamp signal differently, and so it's not recording the actual values. Another example is your CFE turbitimeter. If you have an online turbitimeter in your membrane plant, it has to be spanned. The upper limit has to be at least 15% or 10% over the value at which you get a violation for high CFE turbidity. So, if you only have your CFE turbitimeter spanned to 1.0 NTU, and that's the actual point at which you reach a violation, it's the Turbidity and control system are never going to tell you that you had a violation. So you have to span it to read at least 1.1 NTU. If you look at the checklist and the companion document, there's a lot more detail on what I'm talking about. Next one is one, this is one of my favorites, not because it's bad, but because it's interesting, is if you have recurring turbidity spikes during your membrane filter operation, and those are, typically happen right after a backwash, a chemical clean, a DIT, or some other process. When you see that, you need to figure out if this is air bubbles or suspended solids. And here's a brief little procedure. If during the spike, collect a grab sample from your turbidmeter drain, let the sample sit for a few minutes, measure the turbidity again, and if it was air bubbles, the air bubbles will clear out. If it was solids remained in there, and let me say, if you've let the little sample bottle sit there for 5 minutes and you can see that solid particles settled on the bottom, you need to gently stir it again to get those suspended to reread the turbidity. But in general, if you do that, turbidity stays the same. You're dealing with actual suspended solids. If the turbidity drops, it's probably from air bubbles. These spikes can, at the beginning of a filtration cycle, they can last, 30 seconds, 10 minutes. It's almost always at the beginning of a filtration cycle. Just want to be clear, you're not allowed to exclude those spikes from your reported data. I've been to plants where they say, well, we don't, we have spikes during the first 5 minutes. We don't even report data during that first 5 minutes of the filtration cycle. No, all your data is reportable and you can't exclude any data. So that's why when I go to these plants, I tell them there's no reason that any low pressure membrane plant should be dealing with recurring turbidity spikes, particularly spikes that are impacting the data that you report. It's troubleshoot and fix the problem, because in most cases you can, fix the problem. So how do you fix the problem? Well, if the problem is air bubbles, there are bubble traps that can remove the air ahead of turbidimeters. We've seen different kinds of bubble traps. Some are more successful than others. If the actual problem is your turbidimeter sample line is getting drained, when it's not filtering, so it's actually got air in there, you need to figure out how to either keep water in that sample line or refill the sample line before you start filtering, so that you're actually measuring water turbidity at the beginning of the filtration cycle, and not, there's still air clearing, not just bubbles, but, complete air that's going through your turbidimeter at the beginning. If the problem is suspended solids, there's something that's depositing particles in your filtrate line. We've seen cavitating pumps can shed particles. Chemical cleans can sometimes precipitate particles. It's specific to your source. You're going to have to do some investigation to figure it out. And once you've identified the likely source, figure out a way to remove or eliminate those particles from before the filtration cycle starts. There's a lot more common issues listed in the checklist and discussed in the companion document. I could keep going on, but I know we're almost out of time. So what are some of the things that TCEQ is doing with low pressure membrane plants? So all new or significantly modified low pressure membrane plants must undergo an on-site evaluation by TOP. That's the team that I'm on. And you won't get authorization to send water from the new units or whatever you're building until we've done the evaluation, we've given you a list of things you need to correct, and you've corrected them. Then you'll get authorization to send water to distribution from those new facilities. And as I mentioned before, we're always encouraging you to ask for technical assistance. Deal with this outside of a compliance investigation if you can. I do mention that we've started training PWS investigators on low pressure membrane requirements. So they're a little more knowledgeable of what's going on. So you may, during your compliance investigations, you may come across an investigator who's a little more savvy about how the low pressure membrane plants are supposed to work, and they may even go through parts of the checklist. So just want you to be aware of that in advance. If you're considering low pressure membranes, please give your engineer and your vendor copies of the checklist and the companion document, and tell them that they need to design the facility in compliance with that checklist. That'll keep you out of a lot of problems. It'll make our on-site evaluation just a lot easier. We go down and everything's good, man, you can get your authorization to send water almost immediately. So if you need any additional assistance, honestly, for low pressure membranes, probably our FMT providers can't help you a whole lot. You'll probably need to come back to TOP or the folks that are listed at the end of the checklist. But if you have other problems, I like to put in a plug for FMT. This is how you can reach them, fmt@tcq.texas.gov. It's always free assistance. And here's my contact information. Another discussion of how to get to the website. You go to our main site and then search for low pressure membrane checklist. Well, thank you all for coming, and I hope you all have a safe trip home wherever you're headed today, and just have a great rest of your day. All right, thank you.